Welcome, IT changemakers, to the DEX Show with Tim Flower and Tom McGraw. Let's get into it.
Hello, everybody. Welcome back to Reality Bytes. We have a pretty full team. In fact, I think we have minus Tim. We have the entire Reality Bytes panel. So we've got Dina, Oriana, Sean, and Megan. And as listeners will have noticed, we are really delving deep. We are preoccupied with AI and the implications of AI for DEX and for the future of DEX. And we've been having across the DEX show a lot of fun with this topic. All really enjoying it. And then our very own Megan Brake, she recently stepped up this week and contributed a quite brilliant blog to the Nexthink blog, and the link will be in the description as ever. And it's called The History of AI in the Workplace, Megan. And it reminded me a little bit, Megan, of there's one of my favorite writers about tech is a guy called Charles Petzold. Have you ever read him?
Not that I know of, but maybe.
He's got a book called Code, The Hidden Language of Computer Hardware and Software, where he kind of walks you through the development of computers from the very, very first kind of mechanical adding machines. And he does it so incrementally and slowly and clearly that you could almost convince yourself that you understand the technology as you move through the book. Wonderful writer. We're actually going to reach out to him, see if he'd like to come on the show. But this remembrance, Megan, was prompted by your excellent history of AI in the workplace. So you go back in it, right, to the very beginning of the earliest origins of AI. And I thought this would be a great place to sort of tee up the wider discussion, Megan. Tell us about those origins, and don't neglect Eliza, the first interactive chatbot, who certainly caught my attention.
I certainly won't. Yeah, my first draft of that article was, I would say, twice the length of what is currently published, and went all the way back to like the invention of statistics and probability modeling.
Nice.
Yeah, because that's, like the AI that we see today with machine learning, it basically has its roots in that mathematics. But yeah, so the development of AI, I mean, it was in like sci-fi novels, right? Like the idea of computers that could make decisions like humans was this like sort of intriguing idea. And then you have famously Alan Turing. He makes the Turing machine, which was, I believe, more theoretical than actually practical, and the Turing test, which is that test, can you tell the difference if it's a machine or a human? Intriguing and controversial test to test if AI is really effective. And then you had this scientist, McCarthy, who there was this Dartmouth Conference in the 50s, I believe, where he brought together kind of all the best sort of computer researchers working at the time, and said, essentially, let's try to see if we can make computers make decisions like humans. And those sort of first approaches used a programming language that he had come up with called Lisp programming. And it was a rules-based approach. So if this condition, then this action, and trying to create computer programs and computer algorithms that could sort of simulate human decision-making with if-then. So could you feed it enough conditions that the computer could make a decision and you would think it was a human being making that decision? They were limited by basically the computational power and the memory available in computers in the 50s and 60s, because back then computers took up an entire room. So, they didn't really, they weren't really successful, but they were trying to create computers that could make medical diagnoses, because they figured, doctors sometimes get it wrong, or it takes too long to make a medical diagnosis and people suffer. So they kind of were trying, I think, to eliminate some human suffering by making computers that could make medical diagnoses. So that was kind of the 50s. And then in the 60s, you have this release of Eliza, which is this really intriguing computer program, which I found out yesterday as I was reading more about it, was actually made by a researcher at MIT who was trying to show how basically simple human and computer interaction was, like how superficial. But he made this program that was modeled after a Rogerian psychotherapist, which is that kind of psychotherapy where you say, like, I'm feeling sad. And they're like, why do you think you're feeling sad? And so it's just kind of, they say what you say back to you.
Okay.
And there's still a version of it. You can find it online. It's hosted by, I think, New Jersey Institute of Technology. So I opened it up this morning. It pops up. It says, hello, I'm Eliza. I'll be your therapist today. And I said, hi. Yeah, I said, hi, I'm feeling tired today. And it said, did you come to me because you're feeling tired today? and I said, no, I feel happy. And it said, tell me more about such feelings. So it's very simple, right? It just kind of spits back kind of exactly what you've said or like a rote response. But apparently in the 60s, they released it to some people, and there were people who thought they were speaking to an actual human being.
Sure.
So, at least back then, I think today, like with our experience with computers, we would obviously see through it. But at the time, I mean, it fooled people. Some people thought they were talking to a human and actually had like an emotional response to the conversations with Eliza. So I thought that was a really interesting, sort of first entry point to the development of AI, that
Yeah.
was how kind of computers were being used. So it didn't really enter the workplace in a serious way till the 80s. And I mean, I could keep talking. I'm basically reciting
Well,
my whole thing right now, but
you're ahead of my next question, Megan, which is
mm,
because I think you do hone in very nicely in the article on the fact that those origins, which you just described, are explicitly benign, shall we say, right?
mhm.
They're both developed in order to help people, and I think that kind of feeds into your overall kind of conception of what AI is, or at least should be. And we'll
Yeah.
come back to that. But for now, yeah, the entry into the workplace is precisely where I hoped you go next anyway.
So basically they continued research in that rules-based system that I was talking about earlier, right? The list programming, the if this, then that. There was another one in Europe that was if certain conditions, then certain conclusions. But it was still sort of if then logic. And after the whole medical diagnosis thing didn't really take off in the 50s and 60s, a lot of funding disappeared. But there was the invention of what they called an expert system, where you basically fed a bunch of knowledge into these computers. And in the 80s, you had the release of the first PCs, I think, right? Like the first like DOS computers. And so that kind of revolutionized computing in a huge way, right? In a huge way. All of a sudden, computers didn't take up a whole room. Everybody could have one. And what that also meant was you didn't just have one central IT team who controlled the mainframe, who were the only ones who could build applications and build ways to use computers. Now you have all these individual computers, and it, like we talk about today with DEX, it kind of democratized building out computer programs and applications. And so you had these expert systems, which were these sort of if-then logic that could help, I believe, build these applications and could kind of like know things. And these started to get used in the workplace, I think, by computer programmers to help them build different computer kind of applications. But they had some limitations. I think full-scale automation was the goal with an expert system, that you could just tell it to do something and it would do it. And it couldn't really achieve that. And some of the articles I read suggested that IT teams who were used to having centralized control of everything were a little peeved, should we say, that suddenly like everybody felt like they had a right to engineer the workplace computers. So, the expert systems did fall out of use sort of towards the mid 90s, I think. The last sort of surge of them is that famous IBM computer. I forget its name right now, Deep Blue or something, that beat a chess player in a chess game. So that was sort of the last like famous expert system, because it knew if someone does this play, I do a different play, and it was able to beat a chess master in a timed game. But that's kind of the last example of an expert system. And then they sort of fell out of use. And intriguingly, like that rules-based technology that basically half a century of AI research have been dedicated to isn't really the technology that underpins the generative AI, the predictive analytics, everything we're using today, the whole AI revolution that we're experiencing right now is based on a different technology that was also invented in the 50s, but just was like disregarded by researchers for like half a century until they reconceptualized it. Yeah. The neural networks, they're called. Pedro talked about it when he was on the podcast. He talked about actually how he noted like, oh, we could have invested more in neural networks earlier. Yeah. It was that comment that he made that made me ask. I started my research using ChatGPT for this article.
Yeah, naturally.
And I said to ChatGPT, like, can you tell me the history of neural networks? Because Pedro had mentioned them. And yeah, they were first invented in like conceptualized basically in the 40s. And then there was something called the perceptron that was invented in the 50s. And I'm not going to pretend that I have a complete comprehensive understanding of how neural networks work, because I don't. I think you have to get like a PhD to do that. But they basically have like weighted neurons. It's meant to kind of model, I think, a neural network like what humans have.
Right.
Yeah, and so they were sort of invented back then, but I think we're not very sophisticated. And so we're not the emphasis of AI research. But then it was reconceptualized in the late 90s as machine learning. And that has exploded into what we see today with the computational power and everything, the incredible data lakes we have today. Like that technology just took off. So I did think that was interesting that you had sort of 50 years of research into one topic that went away, and then it was something else from the beginning that ended up spurring what we see today. I thought that was interesting.
100%, and we'll come back to you. But before we do, let's hear a bit about neural networks from our very own 6 PhDs, Dina.
No PhDs yet, so let's just keep it as simple as possible.
Gotcha.
The neural networks. Imagine your brain has tiny helpers called neurons, and they pass secret notes to each other. And when you see, or when they see a picture of a dog, some of the neurons get super excited and say, "Oh, hey, it's a dog." So the neurons talk to each other, and then they they have their own special paths that are called connections,
Mm-hmm.
and they start to build actually connection next to a connection, and they start to build a neural network, which is like a team of these magical neurons working together. So they solve a puzzle. It
Mm-hmm.
becomes bigger and bigger and bigger, recognizing shapes, recognizing examples, or learning from examples. And once they do recognize a shape, they go to the bigger one, build more neural networks, build more connections. So over time, they become super good at things like recognizing dogs, cats, even faces and photos.
Mm-hmm.
So how does the neural network work? Or it actually transformed the AI by combining all of the historical context and the great stuff that we've heard before into bigger mathematical insights, into breakthroughs, and shaping the field as we know it today. So all of this is very nice theoretical conversation. What does that mean to a day-to-day human being now is,
Mm-hmm.
example, that's what you use in the facial recognition. That's the logic and math behind it. That's the science behind it. Social media, healthcare, natural language processing or NLPs, and all of those things are the core of building AI. So whether we used any form of AI in the background to actually ask us or ask, and we get those answers to start where we go. This is how, in very simple format, which I hope was clear, to actually show you how we can build on top of it. And all of the great inventions and progression of AI is based off of that in simple form.
It's a wonderful definition, Dina, and I think I followed it. I do have a question for you. Dina, out of interest, when it comes to distinguishing between kind of digital technology per se and AI, how clearly do you feel able to make that distinction?
So back to the example Megan was speaking about earlier, with what back in the days. Right now, I think the most distinctive part is going to be the emotional part, right? We can go and play around that emotional part. This is something that AIs, or yeah, so far AIs, they cannot distinguish much. However, it has to be in something that they have pre-programmed to do, or patterns that they have seen. So once you start to teach them how to identify human behavior or how to identify emotions and explain them, which is going to be amazing if we can do that, because it's very, very simple in its core. However, human or feelings are very hard to explain and pinpoint because they don't even have a regular pattern. It could be all explorative, it could be all guessing game kind of thing. So as long as you're keeping your questions or the asks that we try and get to AI into a very mathematical or theoretical analytical format, that's super. It's very easy to identify that. But when you start to navigate into the feelings aspect of things, that what makes humans humans,
Mm.
it's not just the decision making. It's going to be a little bit harder to identify. However, I know AIs now are learning better from the pattern of things, and we still, if we play on that silver lining for now, I think we're still ahead of the game. We're able to easily identify when it's confusing when it comes to feelings, or how do you feel about that. If you're tired and then sad and then hungry, how would that make you feel, etc., etc., or react into a certain situation. So putting feelings in the mix, I think, would impact the answer. So if we try and do that and we don't get the right answer, then we can safely say the machine was behind that, not another human being.
Yeah, I love it. It's funny how discussions of AI so quickly kind of find themselves centered upon what makes us human, right? Which I think we'll come back to Megan's article's central thesis. But before we do that, Sean, you're somebody who's written quite a fair bit across the DEX Hub on the kind of marriage of AI and DEX. Listening to what you've heard today, what stands out to you most about that potentiality in the light of this history?
Sure. So I think the potentiality of it is probably best expressed with what we already have as one of the features in the Nexthink product for Nexthink Assist. So that's taking our own proprietary AI and ChatGPT, kind of like ChatGPT but on steroids, and it works really well if you're an IT manager, if you're on that side of things, just because you're able to use one single interface, ask questions, for example, how's Teams going? And it will pull up, 50% of devices are experiencing this issue. By the way, you might want to check out X, Y, and Z. And then based off of that, you can actually take actions immediately within Assist. So that is something that's very promising and you have to be excited about if you work in IT. I do think, I was thinking about this earlier. Do you guys remember like Microsoft Clippy? Do you remember like the paperclip thing
Yeah,
that used
sure
to
do.
pop up?
Yes,
So I
the
was
one
thinking,
with popping eyes.
yeah, it was very annoying and it was only around for a few years and then they pulled it. So that's kind of on the other side of the divides for us, for end users, for employees. And that clearly, it wasn't technically an AI feature, but it was trying to like prescribe or
Yeah.
figure out what you were doing. Obviously, it had very limited technology. So that would be the extreme comparison of something like Assist. For us, I haven't seen anything yet that's sort of helping you out on screen. Now, it probably exists somewhere, but I also think it brings up a lot of questions as if you even want that. So it's sort of like having a colleague in the room with you, helping you out for certain projects, but do we really want somebody kind of over our shoulder at all times suggesting things? And like Dina was saying, this also gets into like the emotional side of work, right? You're on a team meeting and some people maybe inspire you. Some people bore you. So it's like, do you want to add more colleagues to the mix when you're trying to focus? So it has to be, my point is simply, it really depends on the future for end user technology when I'm viewing it from my side. But for IT managers, it seems to be quite promising.
I'm shocked, Sean, that any of our colleagues bore you, but I will
Absolutely none. None on
move
this
past.
call.
Theoretically,
In theory, exactly.
it could be that you're on a team call. Excellent. So I think Dex reintroduces the human into this picture pretty forthrightly, Megan. But you make the argument, as I've mentioned, that the history of AI has been specifically human from those early psychological and medical applications or attempted applications. And the AI is do I have this right? It's like an intrinsically human-centric technology, or that it should be.
Yeah, I think should be is probably a better take. I was struck by those first applications, those first sort of thought experiments were in pursuit of resolving some kind of human challenge.
Yeah.
And I do think that the elements of AI that are the most valued and the ones that a lot of conversations going around about AI include anxiety around what's this going to do to our careers, what's this going to do to our society,
Yep.
up all the way up to your 2001. Sorry, I can't do that, Dave. Like leaving the man out in space, right? So you do have that sort of anxiety around AI, but I think where it brings the most value is where it helps us solve our human challenges, right? Where it helps us either make a medical diagnosis faster or in the case of digital employee experience, make employees feel a little bit more relaxed at work and less stressed out about their machines always causing problems. So my sort of thesis for my article is that AI is at its heart a human endeavor, and that it is the most successful when applied that way, and that it makes it a nice pairing with the DEX field, because the DEX is also at its core a human approach, a human-centric approach to IT. And so AI, when applied to this field, I hope will expand rapidly because they're so well paired.
I think that's a really good point. And I'm thinking about it as well. It's an unusually significant, well, it's a hugely significant technology with unusual origins. Excuse me, with unusual origins that don't come from war, effectively, right? Like most of the most significant technologies on that level come straight out of conflict. And these it does seem to have strikingly benign origins. But Oriana, listening to Megan's argument there, how would you qualify or contest this perspective, or how would you what guidance would you say should be paramount as we begin to integrate AI into our lives to this extent, in terms of ensuring that it does remain human centric? Maybe that's a better way of putting it, rather than pitting you against Megan in such a way.
Yeah, I mean, I think fundamentally, Megan and I tend to agree on this idea, right? That there's certainly the ideal that we see, and then there's possibly the real practice.
Yeah.
And I think it's really interesting that Megan brings up healthcare and you bring up war, because a lot of this research and development has been funded by the military, right? Our military. That's where so much of our scientific research funding comes from, even for things like medical technology. And that can be a really great thing, but it's also, there's sort of the marketing perspective of how do we talk about this in a way that's palatable to people. And then there's those applications absolutely exist and are being developed at the same time, right? Those are part and parcel of that research, and they always have been. If you look into all of those labs, for example. So I think the question of what makes something human centric is really one that's super relevant to me, because that's what I studied and what I tried to focus on. And starting with just the medical example, trying to solve a human problem doesn't make the solution itself, in my mind, human-centric. I think what makes technology human-centric is really the idea that it is, as Don Norman, one of the founders of my field, says, life-enhancing and positive. And obviously that's very nebulous in and of itself. So I think we have to ask ourselves, does it actually have that effect for people as a whole in the long term? Because I think it's really easy to take sort of an individual perspective and say, one person has this positive interaction, therefore the system is good, rather than it is possible to have a positive interaction. The system is not necessarily life enhancing. And I think there's a lot of mythologization of technology. I need to find the source for this, but there's a sort of some writing on this concept of like, we create mythology around technology, right? It's very easy for us to build stories around things, to personify things. This is such a human impulse, right?
Mm-hmm.
We're storytellers, we personify things, we anthropomorphize things, right? If you see a dog and you're like, oh, it's smiling. Well, is it smiling or is it baring its teeth? That means something really different for a dog or for a human. It's so easy for us to impose our emotions onto things around us, including technology, right? So this is one of the issues that comes up with things like an AI therapist, right? Is that it can be built in a way that is very deeply flawed and potentially even harmful to humans. And we will still potentially relate to it on this very profound emotional level.
Wow.
I think there's a few specific factors that are important for like an ethical AI system, right? Some of the ones that experts in the field, not me, have brought up are things like, because you can't reverse engineer the decisions, you can't see what factors are going into making a decision. And this is really important in the healthcare example, because it's not just that it's being used to make diagnoses, it's actually much more frequently used in things like health insurance denials. And there, the system is engineered to reduce the amount of spend for the company, right? It's increasing efficiency to reduce cost. That is not human-centric. And one more thing, which I think is really, really important to talk about when it comes to human applications of AI, which is that there are mountains of evidence at every stage of research. We have seen that there's a ton of bias in the training data, and that creates really bad results. And in medicine, there's a ton of research on the bias in medicine, and all of that becomes formalized and then obscured when you put it into an AI. And it gives people, in some ways, plausible deniability for making decisions that are potentially very, very harmful, and that we have seen in the research to be very harmful.
Fascinating, Oriana. Megan, anything you want to add to that and have the last word?
Only that Oriana always elevates my thinking whenever they
Indeed.
share on
All
this
of our
podcast.
thinking,
And
Megan.
I really appreciate that commentary. And all I will add is that that bias element of it, I think, is so important. I mean, everything you said, obviously, is incredibly important to factor in. I definitely was looking at it with rose-colored glasses and sort of an optimistic take. And I do want to just flag, one interesting piece of my research that didn't make it into the article is actually that the Eliza bot was sort of one of the earlier times that AI went out into the world, like where human beings not part of the research were really interacting with it. And it raised a lot of ethical questions about bias and AI that I think Oriana mentioned we're still grappling with today, because Eliza was a gendered chatbot. So it was perceived to be a woman, and that created a lot of biases in the way people interacted with it and the way people considered it and its expertise. And that it was sort of the first time people started asking, how does human bias apply in the development of a machine? And I think that that's a question that we really still haven't solved for, and in fact, sort of forged ahead without considering, in the example that Oriana gave of the data that you train current models on and the bias that gets sort of woven into that. So I do think there's a lot for us to overcome. I think the ideal of AI that is human-centric is something I hope we can strive for. But yeah, I think when it becomes profit-centered and the human rights in the human life is forgotten is when we go astray and we head more towards that dystopia that sci-fi writers have been warning us about for decades.
Fantastic and fascinating. And you can read Megan's article on the Nexthink blog, not on the Hub. There'll be a link to that below. And if you want to explore the implications of AI for our industry, for the DEX industry, for IT in general, you would do very well to book your place now at Experience 24. It's in Boston on the 15th to the 16th of October. It's in London to the 5th and 6th of November. So hopefully there's some way of getting to one of those two locations. If you can, it's absolutely free, and you'll see some of some representatives of world leading digital workplaces and many, many other things besides. And there will guaranteed be some very, very in-depth and intriguing explorations and demonstrations of the power of AI today in DEX. So please do check that out. You can also find those links in the show notes. Just remains for me to thank everybody, particularly you, Megan, for writing and bringing us that brilliant article. And I'll see you all very soon.
Bye.
To make sure that you never miss an episode, subscribe to the show in Apple Podcasts, Spotify, or your favorite podcast player. And if you're listening on Apple Podcasts, make sure to leave a rating of the show. Just tap the number of stars you think the podcast deserves. If you'd like to learn more about how Nexthink can help you improve your digital employee experience, head over to nexthink.com. Thank you so much for listening. Until next time.